My dear students, today we are going to discuss the Schrödinger's wave equation and its importance. In this program, ఈ ప్రశ్నకు బదులేది. First question in the program is the correct time independent Schrödinger's wave equation for an electron with E as total energy and V is potential energy. The first bit is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m h square 8 pi square by m h square into E minus V into psi is equal to 0. Second one is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi m by h square into E minus V into psi is equal to 0. Third one is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square to E minus V into psi is equal to 0. Fourth one is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi m square h by h to E minus V into psi is equal to 0. You can know the correct equation, Schrödinger's equation, after knowing the information of the Schrödinger equation and its importance. The actual equation is 3. This is the correct equation. Schrödinger wave equation is based on classical wave mechanics, de Broglie's dual nature of the matter waves, and conservation of the energy. De Broglie's actually the Schrödinger wave equation is developed on the basis of these three: classical wave mechanics, hypothesis, de Broglie's hypothesis of dual nature, that is particle nature and wave nature of the electron like particles, and conservation of energy. So, all is the correct one. Quantum mechanics explains the wave nature of subatomic particles like electrons, atoms and molecules, and particle nature of the matter. So, quantum mechanics develops or deals the dual nature of the particles. So, wave nature and particle nature, both is the correct one. Wave nature of the big particles, it is not applicable, only smallest particles like electrons, atoms and molecules only it is applicable. C is the correct one. So, but actually the quantum mechanics and Schrödinger wave equation detailed information we need not bother, but the equation and the terms, explanation of terms and the importance of the terms is the very essential for intermediate students. Schrödinger's wave equation. Schrödinger is the scientist name. Erwin Schrödinger developed a quantum mechanical model of the atom. He got Nobel Prize for this equation, which treats electrons as a matter waves. Electrons has dual nature. Electron has a particle nature and a wave nature. On the basis of this, Schrödinger developed a quantum mechanical model for the atom. Schrödinger equation is the fundamental equation for quantum mechanics. It is the basic equation for the quantum mechanics, first equation you can say. It is based on dual nature of the matter proposed by de Broglie. So, de Broglie wave nature, particle nature, de Broglie proposed wave nature and particle nature, that is the dual nature for the matter particles like electrons and small atoms and molecules. So, it is based on the de Broglie concept of the dual nature of the particles. It describes the behavior of matter waves and it also explains the presence of multiple orbitals in an atom or fine spectrum. Generally, Bohr's theory is applicable for one electron systems like hydrogen and hydrogen like atoms, helium plus, lithium 2 plus like that. And it could not explain the fine spectrum also, but Schrödinger wave equation helps to explain the multiple orbitals in an atom and the formation of fine spectrum also for the atom. It is derived system for systems such as an electron or atom or molecule whose energy does not change with time. So, it is only applicable for the particles whose energy does not change with time. That is important. So, it is simply we say quantum counterpart of Newton's second law of thermodynamics, classical wave mechanics. It is a quantum mechanical form of the, we can consider this equation as a quantum mechanical form of the Newton's second law of thermodynamics, this classical wave mechanics. It is a second order differential equation. So, you can know the differentiation, the first time differentiation, after coming the product, if you differentiate another time, that is generally used to say second order differential equation. In mathematics, you can know the secondary, especially in secondary intermediate, you know the differential equations. In that, what is first order and what is second order differential equation, you can know. But we should know Schrödinger wave equation is a second order differential wave equation. This is the Schrödinger's wave equation. We can read like this: dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square plus into e minus b into psi is equal to 0. Here psi is wave function. M is the mass of the particle, h is Planck's constant, E is the total energy of the particle, B is the potential energy of the particle. In some books, instead of B, U also written for the potential energy in the equation of Schrödinger's wave equation. So, it is also written as H psi is equal to E psi. H is the Hamiltonian operator, H into psi is equal to E is equal to energy into psi, energy, total energy of the particle. This is. So, how can we derive from the Schrödinger's equation, Schrödinger's wave equation? Dou square psi by dou x square, it is a Schrödinger's wave equation form, full form. Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus b into psi is equal to 0. This instead of this operator, you can instead of this part that is second order, you can write del square or delta square. You can say, right, delta square psi. Delta square is nothing but dou square psi by dou x square plus dou square psi by dou y square plus dou square psi dou z square. If you remove the psi's from this, that is delta square. So, if you add, put psi along with the delta square, so that gives this part, delta square psi plus 8 pi square m by h square into e minus b into psi is equal to 0. So, on opening the brackets, open the brackets, then you will get this type of equation: delta square psi plus 8 pi square m by h square into e psi minus the 8 pi square m by h square into b psi is equal to 0. So, if you put e psi here, LHS, and the remaining you bring towards R right side, RHS, as RHS. Then what happens? You see, del square comes this side, so minus del square psi. Del square psi will be minus del square psi plus 8 pi square m by h square. It will be minus will be plus, so plus 8 pi square m by h square b into psi. Here, this is the factor for multiplication factor E 8 pi square m by h square to the e psi. That if you bring this towards this side, so what's that is the right side. What happens? 8 pi square by m, this is cancels out, but it also divides this one. While dividing, it will be inverted. So, minus h square 8 pi square m del square plus b into psi is equal to h psi. This is h. This is called a Hamiltonian mathematical operator. Hamiltonian means, it is not actually a scientist name. Hamiltonian means a function used to describe a dynamic system such as motion of the particle. So, dynamic system, to explain the dynamic system, a function is used. That function is called Hamiltonian function or Hamiltonian operator. H is a Hamiltonian operator. It is a total energy operator. It is also called as total energy because h psi is equal to E psi. H instead of H represents the E. E is total energy. So it is also called as total energy operator. H is potential energy and kinetic plus kinetic energy. T is not total energy, it is kinetic energy plus V is potential energy. So this operator of Ke, the operator of Ke should be same for all models. For all models means there are so many models in the quantum mechanics, particle in the box, particle in open box, like that. So many models are there. It is actually it is not necessary for the intermediate students now. So should be same for all models, such models, but P changes as per the parameters given. As per the parameters, potential energy changes, but kinetic energy is same for all models of the quantum mechanics derivations. So write the importance of psi and psi square. Psi and psi square. Psi is a wave function. Psi is a wave function and refers to the amplitude of the electron wave. Psi is a wave function. This is amplitude, height of the crest and depth of the trough. This is the amplitude. Psi indicates the amplitude of the wave. Amplitude of the wave. But it has no significance. Psi has no significance. Psi is not at all used to describe about the electron. But instead of psi, if you take psi square, that is useful. Why psi is not useful and psi square is useful? Psi is sometimes it takes plus value at the crest. At troughs, psi as the amplitude is the minus. Amplitude is the minus. Probability minus is no meaning. Probability plus is meaning. Probability of finding the electrons plus is meaning. There is an existence. Minus is no meaning. So to avoid that is the reason it has no physical significance. If you take psi square is always positive. Minus psi whole square or plus psi whole square is equal to psi square. So it is a positive. So it is taken as a probability function. It is taken as a probability function. So psi square is called a probability function. It indicates the probability of finding the electron, probability of finding the electron at a point in an atom. So in an atom, where if you take a point, whether the probability of finding the electron is maximum or zero. If zero probability of finding psi square is zero, that is called a node. If psi square is a maximum, that is called orbital. Later we will learn in next videos. Psi square is a probability function. Psi has no significance. Why instead of psi square is taken? Because psi has positive values and negative values. If you take probability as psi is a probability, there is no meaning of minus psi. That is the reason psi square is taken. Psi square is always positive. Psi square is always positive. So it is taken as a probability function. It indicates the probability of finding an electron at a point within the atom. Thank you. Subscribe for more information.